Okay, dear students, welcome to this class. So already in our last class, we had been regarding about in this chapter the main types of chemical reactions. Remember how many are there total? Four kinds of chemical reactions are there: chemical combination reaction, chemical decomposition reaction, displacement reaction, and double displacement reaction or double decomposition reaction. Okay, so already we have learned clearly in the last class about the first main kind of chemical reaction, that is chemical combination reaction, and also about exothermic reaction. So once again I wish to recall that, see, combination means two or more reactants combined together form only one product. Yes or no? Yes. So that kind of chemical reactions are called chemical combination. Combination reaction. Remember, two or more reactants combined to form only one product. Yes. Okay. And also in some combination reactions, heat is released. If heat is released in the chemical reaction, so that kind of chemical reaction is called what? Exothermic reaction. What it is? Exothermic reaction. Yes or no, students? So I said some examples for that: respiration, even burning of natural gas like methane. So in these two reactions, energy is released. Energy is released. Heat energy is released. Even our respiration also, in the time of respiration, our food will break down into simpler units like glucose, and it burns with the oxygen, and it releases the energy. Hence we say respiration is also considered as what? Exothermic reaction. Clear or not, students? So let us come in this class. You will go to learn about the second main chemical reaction, that is chemical decomposition reaction. Chemical decomposition reaction. See, word is a decompose. Combination means two or more reactors combine. In this case, decomposition is there. Opposite of that combination. What happens actually in combination reaction? Two or more reactants combine together form only one product. Yes or no? But here totally opposite of that combination. So one reactant or one compound breaks down to form many substances, many simpler units. Understand? Here in this kind of chemical reaction, let's see with example. After that I will say that. Take an example, calcium carbonate. What it is? Calcium carbonate is there. Just give heat it. Already know that, students. This delta symbol that indicates the reactant is heated. The heat is given to reactant. Yes, okay. So when you heat this calcium carbonate, it decomposes to form calcium oxide, and also releases carbon dioxide gas. See, only one reactant is there, one compound is there. It decomposes to form simpler units, many simpler units, more than one simpler units. So here two products are formed. Reactant is only one is there. Products two are there. Opposite of that, combination reaction. What happens in combination? Two or more reactants combine to form only one product. Understand? Here one reactant decomposes to form more than one product. That's all. So this is called what? Chemical decomposition reaction. See, the calcium carbonate. This compound name is calcium carbonate. It is generally called as a limestone. What it is? Limestone. And it forms what? Calcium oxide. Its general name is a quicklime. What it is? Quicklime. Understand? So when you heated the calcium component, it decomposes to form calcium oxide and carbon dioxide gas. Take another example. Ferrous sulfate is there. What it is? Ferrous sulfate. When you give heat to this ferrous sulfate, either just heat this ferrous sulfate, that forms what? Fe2O3, ferric oxide, and two gases. One is sulfur dioxide and another one is sulfur trioxide gas. Understand? Then you have to balance it. What is ferrous sulfate? This is what? Ferric oxide. Ferric oxide. Clear? See. Here also one reactant is there, which is that ferrous sulfate is there. When you heat this ferrous sulfate, it decomposes. Decomposes means what? Breakdown. The single reactant breakdown to form more than one product. Here, when you heat this ferrous sulfate, it breaks down to form three products. Which are those? Ferric oxide, sulfur dioxide, and sulfur trioxide. Sulfur trioxide. Understand, students? Let's see another example. Take a silver chloride. Understand? Take a silver chloride. Just expose that silver chloride to the sunlight. Understand? Just expose silver chloride to the sunlight by utilizing the solar energy, solar heat. Understand? Heat of the sun. This silver chloride decomposes to form silver and chlorine gas. Silver and chlorine gas. Understand? Here, this compound, we are giving directly heat to this calcium carbonate and it breaks down to form calcium oxide and carbon dioxide. Here another compound is there, ferrous sulfate. Here when we are giving heat to this ferrous sulfate, when we heated the ferrous sulfate, it also breaks down to form ferric oxide, sulfur dioxide and sulfur trioxide gas. See the last case, silver chloride is there. When you expose to silver chloride to the sunlight, it also decomposes or breaks down to form silver and chlorine. Same case happens in also silver bromide. What? See, in case of silver bromide, same, when we expose that silver bromide to the sunlight, it also decomposes to form silver and bromine. Silver and bromine. Just balance this equation. Understand? See. See in the reactant side. How many reactants are there only? One reactant is there. Calcium carbonate is there. Ferrous sulfate is there. Silver chloride is there. Silver bromide is there. So when you heated all these reactants, they break down to form more than simpler units, more than one products. Understand? So such reactions is called decomposition reaction. Understand? See students, here we are giving heat, but observe these two reactions. In these two reactions, we not heated these reactants. We just expose these two compounds to the sunlight. We are not heating it. Understand? We are not heating them. We are just exposing that silver chloride and silver bromide to the sunlight. By utilizing the heat of the sun, they break down to form more than one product, that is silver chloride and silver bromide. Remember, this silver bromide, in ancient days, it is used in a black and white photography. Black and white photography. Black and white photography. Which compound? Silver bromide is there. Understand? See, I will say another example. Here water is there. What it is? Water is there. Can you separate oxygen this water physically, either by giving heat, either by exposing it to sunlight? No, it is not happen. It is not possible. Take a water in your beaker. Take any bowl. Just pour that water and expose to sunlight. So that sunlight is separates the oxygen and hydrogen from water. No. How, sir? How can we separate this oxygen and hydrogen from the water? Yes, it is possible. We can also separate hydrogen and oxygen from water by the not heat, by not sunlight, by the electricity. By the electricity. Understand? So by passing electric current to the water, we can easily separate hydrogen and oxygen from the water. Understand? See students, depending upon giving heat, based on this decomposition reactions are classified into 3 types. So here in this case, this reaction we call it as a thermal decomposition. What is thermal? Thermal means heat. We are break down this compound by giving heat. Here also see calcium carbonate and ferrous sulfate is there. Here we are breakdowning these two compounds by heating them. We are just break down that two compounds by heating only. So such reactions are called. So this is called what? Thermal decomposition. This is thermal decomposition. Another name is that this is called thermolysis. What is thermolysis? And in second case, these two compounds, silver chloride and silver bromide, these two compounds are broken down into more than one product. Not by heating, when we expose these two compounds in a sunlight. Understand? If the decomposition reaction takes place with the help of sunlight, so that is called what? Photolysis. That is photolysis. Understand? See students, all are decomposition reactions. Here these compounds are decomposed by the heat. Here two compounds are decomposed or breakdown with the help of sunlight. So this process we call it is photolysis. And here one compound is there, water. Here we are break down that water molecule into hydrogen and oxygen by passing what? Electricity to it. Hence this process is called electrolysis. What it is called? Electrolysis students. Understand? See. So electrolysis. These are the types of what it is? Chemical decomposition reactions. First one is the thermal decomposition or thermolysis. Here we are break down the compounds by giving just heat to them. Understand? In second case, photolysis is there. Here two compounds, especially silver chloride and silver bromide, when we expose that compounds to the sunlight, they themselves break down to form silver and silver chloride, silver and bromide. Understand? So this process we call this photo. Photo means light. Photo means light. Lysis means breakdown. We are break down the compound with help of sunlight. Hence it is called photolysis. The last one is the electrolysis. Understand? Electrolysis. A simple experiment is there. How can we conduct the electrolysis process? Understand? And diagram is there. So that is asked for your examination. Hence you should practice that diagram. Okay students? I will explain clearly about the electrolysis of water. Just watch it. After seeing all these examples, we can now say what exactly the chemical decomposition reaction means. Okay students, what happened? When we are heating the single reactant, that breakdowns to form more than one product. Hence we call it is chemical decomposition reaction. See, definition says that the reaction in which a single reactant breaks down to form more than one product. more than one product. So such reaction is called what? Chemical decomposition reaction. Understand? Chemical decomposition. Very easy to understand. Understand? The reaction means single reactant breakdowns to form more than one product is called chemical decomposition reaction. Clear or not? Okay, let's see. Electrolysis of water is there. Electrolysis, it is also a type of that decomposition reaction. Understand? Here for your syllabus, electrolysis of water is there. That means even we can also break down the water molecule, not by heating, not by exposing to sunlight, just by passing electricity to it. How, sir? Let's watch. See students, electrolysis of water is there. We can easily separate the oxygen and hydrogen gas present in water by passing electric current through it. So that process is called what? Electrolysis. Understand? So electrolysis means in simple words we say it is a decomposition of a compound. The decomposition of compound by passing electricity. See, the decomposition. The decomposition of compound by passing electric current. By passing electric current. So that we call it as electrolysis. The decomposition of compound by passing electric current, that we call this electrolysis. Here electrolysis of water is there. Understand? To separate hydrogen and oxygen from that water, understand? You have to pass the electric current to it. So to make this experiment, first you have to need what? Plastic mug and 2 graphite electrodes and 2 test tubes and 2 conductors and finally 6-volt battery. Understand? 6-volt battery, and these are called rubber stopper. These are rubber stopper. Okay, dear students, take first a plastic mug and make a 2 holes. Make a 2 holes beneath this plastic mug and fit these 2 rubber stoppers to that hole. Fit 2 rubber stoppers in the 2 holes and take 2 graphite rods. Understand? Take 2 graphite rods and fit that graphite rod inside this rubber stopper and then fill this plastic mug 2/3 of water. 2/3 of pure water. Fill this plastic mug 2/3. 2/3 means 70% of this plastic mug with a pure water. You have to take a pure water which is free from all salts. Don't take a normal water. You have to take what? Pure water. Understand? Take a 2/3 of pure water in a plastic mug. Understand? Then you have to take 2 conductors and connect these 2 graphite electrodes to the 6-volt battery. Understand? See, the electrode, the graphite electrode which is connected, the graphite electrode which is connected to the positive terminal of the battery, which is connected to the positive terminal of the battery, that is called anode. That is called anode. Similarly, the graphite electrode which is connected to the negative terminal, to the negative terminal of the battery, that is called cathode. Clear or no? Anode means positive electrode, cathode means negative electrode. Understand? Then before passing this electric current to this pure water, remember one thing, pure water is a bad conductor of electricity. Pure water is bad conductor of electricity. Hence, you have to make it to conduct electricity. You have to make it to conduct electricity. How, sir? By adding sulfuric acid. Few drops of sulfuric acid. Add a few drops of sulfuric acid and stir it well. Then water becomes acidified. The water becomes acidified. We call it acidified water. This acidified water able to conduct electricity. Understand? Because you know pure water is a bad conductor of electricity. It is a free from all salts. Hence, to make it to conduct electricity, you have to add few drops of sulfuric acid to the water. Then water becomes what? Acidified. This acidified water able to conduct electricity. Then after, you have to pass electric current to this acidified water. Understand? So after passing electric current through this battery to the acidified water, just observe. After 5 minutes, the bubbles are started. The bubbles are started to generate in this both. See, here you are putting invertedly 2 test tubes. Understand? Take a 2 test tubes, fill it with water, and slowly put invertedly on the both electrodes, both graphite electrodes. Then after, you have to pass the electric current. After passing electric current, after few minutes, you can observe the air bubbles are started to generate in the both test tube. When air bubbles are started to generate in both test tube, the water levels goes down. The water level goes down. Understand? See, after passing this electric current, see, in the both test tubes, gases are collected. In both test tube, gases are collected. Observe the gas collected in the test tube A. Observe, this is the A test tube, this is the B test tube. Understand? The gas collected is the volume of gas collected in the A test tube. It is the half of the volume of gas collected in the B test tube. Understand? That means the volume of gas collected in the B test tube, that is the double of the gas collected in the A test tube. By seeing this volume of gas, by seeing this only volume of gas which are connected in the test tube, you can easily identify this is hydrogen gas. This is hydrogen gas and this is oxygen gas. You can easily identify the both gases by seeing their value. Understand? The gas collected in the B test tube, the volume of this gas is double the volume of gas collected in the A test tube. Understand? Because you know, water is made up of 2 atoms of hydrogen and 1 atom of oxygen. When you break down this compound by passing electricity, it breaks down to form hydrogen and oxygen. Question is that, sir, how this hydrogen gas collected in the B test tube and how this oxygen gas collected in the A test tube? Remember one thing, when you pass the electric current to this acidified water, the water breaks into hydrogen positive ions and oxygen negative ions. Hydrogen positive ions and oxygen negative ions. Remember one thing, this positive electrode, here positive electrode is there, which is that anode. This anode always attracts negative ions. This anode, positive electrode attracts what? Negative ions. Similarly, cathode, negative electrode is there. This negative electrode attracts positive ions. So when you pass the electric current to this water, the water breaks down to form ions as hydrogen H plus ions and oxygen minus ions, positive ion and negative ion. So these hydrogen ions are attracted by cathode and oxygen negative ions which are attracted by anode. Hence, oxygen gas collected at A test tube, hydrogen gas collected at B test tube. Understand, students? This is very clear. Then, after conducting this experiment, if you want to check that is it gas, is it hydrogen and is it oxygen, you can check it. Slowly remove that test tubes from this apparatus. See, take first which test tube B. Take first test tube B. Slowly take the test tube B from that apparatus and just open the tip of that test tube and bring near a splinter. Splinter, either you can use what it is, lighter. Just bring near lighter to that test tube. Understand? Suddenly that fire puts off. Suddenly that fire puts off with a pop sound. That indicates what? The gas collected in the B test tube is a hydrogen, because hydrogen gas does not support combustion. Hence it puts off the fire. Similarly, slowly take out that test tube A from this apparatus and bring the same splinter or even you can use a lighter. Bring near to the tip of the test tube and observe the flame brightly is started to fire again brightly. Understand? See. So that gas, which is that oxygen gas. Understand? Because that oxygen supports the combustion. Understand? That oxygen supports the combustion. So by using the splinter or you can lighter, you can check the gases collected in a bore test tube. Understand? If the flame of that lighter, either you can say what it is, splinter. If it burns again with brightly, remember that gas is oxygen. If the flame suddenly gets put off, just imagine that gas is a hydrogen. So this is what we call electrolysis of water. So students, it is asked for examination in a 2 to 3 marks. Hence, you should practice this diagram. You should practice this diagram neatly. Clear enough, friends? So what we have learned in this class? Second main kind of chemical reaction, that is chemical decomposition reaction. Understand? Decomposition means what? So the single reactant breakdowns to form more than one product, that is called chemical decomposition reaction. Depend upon the giving heat. Based on that, this decomposition reactions are classified into three categories: thermolysis, photolysis and electrolysis. In thermolysis case, we just break down the compound by giving heat. In photolysis, we just break down the compound by exposing them to sunlight. In third case, electrolysis, we break down the compound by passing electric current to it, and it is called electrolysis. Clear enough, friends? In next class, we will discuss about the next kind of chemical reaction, that is chemical displacement. Thank you for watching this class.